Hello, everyone. A warm good morning to all of you who are present today for this Spark AI Hackathon workshop. Thank you for being here with us today. Uh, this workshop today intends to, through this workshop, we intend to teach you how to create your own Spark AR effects, which you would be required to submit after the workshop gets over. The purpose of this activity is not only to train you all into creating your own unique effects, but also to guide you on the options that you have, the understand and make you understand the career possibilities that are arising and emerging in the field of augmented reality. So we have with us Adil. Adil is going to be your mentor for today. This is going to be a hands on workshop. So we would request all of you to follow what Adil is saying, practice it side by side. You can post your queries in the chat box and we would be answering every question of yours. Also, please do remember that every submission will get you a Facebook certificate and a goodie bag. And also, we have cash rewards for the top three winners. So we really, really look forward to your attendance, your presence, and your remarkable effects. I'm going to hand over the virtual stage to Adil now. Thank you.
So, hello students. Yeah, thanks, Anamika. So, hello students. So, in this workshop, I just split it into four parts. So, there will be a four separate small set of filters. You will be creating each one of them as well. And if you have any doubts, you can ask in the comment sections. So, I will be interacting there as well. Yeah, hello, Saurav. So, okay, let me present my screen. So, as for this section, we need to install the Blender. So what is a Blender? So Blender is a 3D modeling software. It is used to create the 3D modeling and as for the animation works and for optimization as well. You need to type on Google Blender download and search it as well. You need to go to the first link. By clicking on this download button, you can download the Blender. I am using Mac, so it has been showing the Mac icon. If you are using Windows, it will be showing the Windows. So it takes some time to download. So once you guys download the Blender and complete the installation, just open it. So after completing the installation setup, when we open the Blender, it looks like this. This is the sample scene of the Blender. It has a camera, cube, and light. We don't need this for right now. I'm going to delete all of this. So before explaining more about Blender, so why should we use Blender? So let me open the Spark AI Studio tool. I'm going to create a blank project. if we go to the sketchfab.com, it has the large amounts of models, but some some models have the high poly as well, high poly mesh. Say for example, I type the baseball cap in sketchfab and click on the first model. You can see here this is a simple cap model, but it has 993.2K triangles and 46.6K vertices. So when we import this model in Spark AI, it shows the triangles warning. Because Spark AI supports 50,000 of triangles, it just exceeded the triangles limit. So the size is around 155 MB. I just downloaded it before the workshop. So let me show you. So this is the baseball cap file that I downloaded from the internet. So this is the uh, model files, and these are the textures. I'm going to import this into the Blender. So why Blender now? So the actual size of the model is around okay, the actual size of the model is around 3.2 MB. We can reduce the size by using the external 3D modeling softwares like Maya Blender. So the Blender is an open source, so that we can use Blender as well. So I'm just importing the cap model into the Spark AI toolkit. Takes time to load. Okay, it has been loading for a while. We can give a quick intro about Blender. So this is the Blender scene file, and after installation and set up the Blender, you need to go to Edit, Preferences, and then go to the Input as well, and check on this Enable Emulate 3 button mouse. So by clicking on this, you can press the Alt key on your keyboard and then rotate your scene and then move it. So we also need another one of the thing to reduce the triangles, that is named as Sparkcare Blender Toolkit. You need to click on this first link and then need to press the download Sparkcare Toolkit. A zip file will be downloaded which is named as a Sparkcare Toolkit. You need to go to Blender and then go to the Edit, Preferences, and click on this add-on button and then go to the install. And you have to locate the Sparkcare Toolkit that you downloaded from the internet and click on install add-on. So in my software, I have already installed this add-on. So you guys should click on this install add-on. So after installing, it will be like this. You need to check this in order to activate in the scene view. So after installing the Spark AI toolkit, a small icon will be hovering here. When you press on this, the Spark AI toolkit has been window will be shown. If you see like this Spark AI toolkit, uh, you will have the confirmation you have successfully installed the add-ons on the Blender. Now we can go to the Spark AI Studio. Now you can see the warning has been appeared here. Triangle count exceeds the recommended limit. Use the Spark AI toolkit for Blender to reduce it. So the maximum amount of triangles that Spark AI supports is 15K, but the triangles here for the cap is around 74,000K. Sorry, the 93,000. So we are going to reduce it by the Spark AI Blender toolkit. For this, we need to import it, the file using the Blender. We need to go to File, Import. The format is in the GLB, GLTF. Now go to Documents, VVLC, search this podcast, see in your GLTF. So this is the cap model that we downloaded from the internet and we have imported in Blender. When I tap on this by viewport wireframe shaded, you can see these are the polygons that has been in the mesh. We need to reduce this polycount and the size will be automatically will be get reduced. For to export the file, you need to go to File, Export, and then select the FTX format. I'm going to name it as cap unoptimized. Then save it. Now you can see the file size is around 3 MB. We need to reduce the file size and triangles count. So before optimization, we can clear the model structure in Blender itself. So this is the transform hierarchy of the model. We don't need the lights and the camera. By right clicking on this, delete window or pop-up window will show up. You need to press on the delete button here. So these objects will be getting deleted. I'm just unfolding this. So these are the meshes. You can see here, when I select one of this, the corresponding meshes has been getting selected. So what we are going to do is to combine all of these meshes into a single object. So for this, in order for this to work, we need to select the corresponding meshes and then go to object and then join. If we select the transform hierarchy and then go to object join, it won't work. So we need to select the meshes that are in the model. By clicking on the control key on my keyboard, I'm just selecting all of my meshes. And then go to object, join. Now you can see all of the meshes are getting joined. These are now the empty transform. So right now we don't need this. So I'm going to delete this. Now, after selecting measures, this is the percentage. This is the amount of percentage that the Spark AI toolkit should reduce the triangles. The maximum is 100, so we need the 90% to clear up. So now you can see the poly count has been reduced. The orange wireframe has been reduced to a 300. Now we can export this file. To export, again, we need to go to File, Export, SPX. I'm going to rename it as Cap Optimized. Now you can see the file is around 387 KB. This is an unoptimized file size, and this is an optimized file size. So I'm going to delete this baseball cap. Now you can see the warning also not showing in the Spark AI Studio because we have the optimized version of the model. So now we can place the cap to the head. We need to right click on the focal distance, add object, and go to the face tracker. And then need to drag and drop this cap optimized model. You can see the cap model is in huge size. We can reduce the size by 0.4, 0.4, 0.4. Still the size is huge. You can see here the other side of the face is not visible. But in order for this to work, we should use the head exploder that we used in the previous day. So as for now, we should go to the for this I need to download the face reference asset file that we downloaded yesterday. We are going to drag and drop the head exploder that we used yesterday. First of all, before making visible, we can make the cap to fit the head by using this head exploder. I think now it's okay. We need to move it to the top in order to the occlusion to get work. And also you need to change the blend mode from replace to alpha because in the replace the opacity won't work. If we change the blend mode to alpha, then only will be the opacity will be work. You can also reduce the cap size. So this is how you apply cap to your head. Now you can see the model does not have the texture. So we need to apply the texture to the model. Oh no. So this is the textures of a model. We can click on this texture and drag and drop it here. That will import to the Spark AI Studio. It is taking time sometimes to load. So now the texture has been loaded to the Spark AI. We can assign the diffuse texture to the texture map and the specular glossiness to the specular glossiness and normal to the normal texture. Now we applied a cap to the face, then optimized in Blender. So this is how you will be downloading model from the Sketchfab and optimized in Blender and use it in Spark AI. So student, this is the part one. If you have any doubt, you can ask in the comment section. In this Blender or Sketchfab or Spark AI Studio, if you guys any doubt, you can ask in the comment section as well. So I hope no one is having the doubt. So let me move on to the next part. So the next part is going to be how we'll be making the randomizer filter in Spark AI. So uh, we will see in the reel stories or posters, someone will something popping around his head. Which character are you, or who is your favorite player, or which movie you like? And a randomizer will be starting like Avengers and then Marvels like this. So we will be creating something similar to like that kind of effect in Spark AI now. So as for this now, I have started profession as a randomizer. So let me tell you how to do this. For this effect also, we need to add a face tracker, and then we have to create a plane by right clicking on this object, add object and plane. I'm going to place it above my user set and make it a square size of making it a little bit wider and name it as start. So I have created the assets for this before the section. Just import this as well. This is going to be the start material. We don't want the effect to be affected by the lighting, so we can change the standard types to flat and then file to be start. Now you can see the start image is over the head. We need to duplicate this by pressing on the start and right click, and we can click on the duplicate button. This will be our randomizer plane. I'm going to name it as randomizer material. So in order for the randomizer, we need to use the animation sequence. We can import the animation sequence by clicking on this plus button and then go to import and then texture animations. So texture animation is nothing but like you can consider as an array of texture. So multiple textures are combined together as termed as a texture animation. We don't want it to be added to the plane. I'm just choosing the file. So these are the textures that I haven't created. By clicking on command or control, you can select these textures and then click on this open button. You can see these textures are formed to show us an texture animation. It's like you can consider it like a sprite sheet or a texture image sequence. By clicking on this import, it will import to the Spark Studio. And we can assign the materials like this. Now you can see the randomizer has been working. But it does not have a start and a stop animations. So in order to get the user input, we can use the screen tap. So say for example, when the user tap on the screen, the randomizer filter will start and it will randomize some of the professions, and then it will choose the any one of the professions as well. So for this, in order to work, I'm just using the screen tap patch and the loop animation. We don't want it to be flipped every time when we tap on the screen. So I just connected it to the turn on patch. So the loop animation, it's the duration that the effort should be completed. Say for example, you can see here the value is 0.02. It will go from end. Say for example, the start value is 0 and the end value is 1. So the transition will be happening from 0 to 1. So with the duration of 1 second, when we change the duration of 5 seconds, the transition of 0 to 1 will be happening in 5 seconds. So this is animation, and when we uncheck this enable, the animation will stop working. So this is as for the how the loop animations is work. So now what we are going to do is to connect this patch to the enable. When we tap on the screen, the loop animation should start, and after 2 seconds, the loop animation should stop. In order to make it trigger after 2 seconds, we can use the delay patch. So the delay patch is used to trigger an animations or anything after some delay. Let me show you. The value patch is used for the debugging purpose here. So now you can see the output is connected to the input with a delay of 3 seconds and then assign it. So when I check this value input to true, after 3 seconds, the value true will be transformed to here. You can see here. When I check the value to false, after 3 seconds, the value will be transformed to false. So this is how the delay patches work. You can delete this. So when we tap on the screen, the the randomizer should start. So and after 2 seconds, the randomizer should stop. So we are using the delay patch here. So after 2 seconds, so loop is an pulse value that will be triggered every time when the animation ended. Let me show you. So what is this random patch does? So we just randomize a value between zeros and one every time when the pulse is triggered. So in order to this to work, our animation should be much as low as possible. So I'm making the value as one. Now when we go to the randomizer animation sequence, you can see the frame here considered here is 4. So the maximum amount of frames here is 4. So what is a frame? Frame is a n number of textures. See, for example, we have 4 textures in this doctor animation sequence. So the start value is 0 and then end value will be 4. And now you can see here the current frame. So we can we can assign the current frame in the patch editor. So the zeroth frames is doctor, and the first frame will be engineer, and the second frame is lawyer, and the third frame is police. So these are the values that in the frame. So now we can connect the value to here. I'm just reducing the value to 0.1 so that it will get animation. See, for example, now when I tap on the screen, the randomizer starts, and after 2 seconds, the randomizer stops. So we are missing something here. We need the start to be visible for the first time, and then the randomizer should be not visible at the time. When we tap on the screen only, the randomizer should be visible. So in order to do this, we can use the not patch as well. So what does the not patch does? It's just inverts the value. Say for example, we are sending here the signal as true. The value will be reversed into the false. Let me show you. Now you can see I am sending a false value here. The false value has been taken into the not patch and then converted the false into a true value. The same here. When I check the value to true here, the value is getted into the not signal and then it's just to reverse the value to false. So this is how the not patch works in Spark AR. Now we can click on this visible button to patch us in both of this game objects. So what I'm doing is we need the start to be visible before we tap on the screen. So that's the way I just connected it to the notepad. And then we need the randomizer to be visible when the user taps on the screen. Now when we tap on the screen, you can see the randomizer gets working, and then we have the randomizer selected as a police here. So this is the simple randomizer filter. You can, by using this, you can create which movie you like, which character you like, or some other examples. So this is for the part two as well. So guys, if you're having any doubts in this, you can ask it in the comment section, or any explanation about more about the patches that you see here. Okay, I hope everyone is good with this patches. So let me save this process. So the next we will be seeing about the world tracking. We will be making use of how to create a world tracking effect from the template. So for this, I will be using the world tracking template from the Sparkia Studio. So this is the world tracking template. When you open the Sparkia Studio, it's like this. When we tap on the screen, the blue cube moves according to where we tap. You can see here. Now, instead of this blue diamond, we will be placing a car, and we will be changing a car in Sparkia. So now we can see how we'll be doing this. So this is the car that we'll be placing when the user taps on the screen instead of the blue diamond. It's a simple car, and we will be also changing the color of the car using the picker UI as well. It's taking some time. So let me tell you what is about the plane tracker is. So plane tracker is nothing but the Spark AR finds an infinite plane when the users view the back camera of the phone. It just tracks for an infinite plane. When the infinite plane is tracked by the Spark AR, it allows us the users to tap on the plane and then place the virtual objects. So in this case, we will be placing the blue diamond. So as an example modified here, we will be Instead of this blue diamond, we will be placing the cars in Spark AI Studio. By using these templates, you can place some animals or plants or buildings or etc. Anything you like in the world AR. So this is how the Spark AR will be working. World tracking will be working. And also the Spark AR variety of you can search it in Google. You can find tutorials in the Spark AR website. It has various set of tutorials for render paths, lightings, and then the custom animations, custom pictures, STFs as well. You can see here these are the tutorials provided by Spark AI. It also has the completed project where you can also modify the project or you can learn something new. There is a tutorial for the particle systems and then particle world effect, and this is the light, how the light is applied to the face. So you can check out this all of these tutorials and then make your own filters or your own unique idea in Spark AI. So now the car model has been imported into the Spark AI. You can see here there is a delete me option. So after importing the model, we need to delete this. And then instead of delete me, we need to drag and drop our car model here and just rename it to car for my convenience. You can see the car is rotating here. So we need to identify where the car has been rotating. You can see here the rotation isn't static. So we need to go to the parent. The parent rotation is also static. Its rotation is 0, 0, 0. So we need to go to the its drag here parent, the looping animation block. Now you can see here the rotation is not static. It has been set by some patch and the value is changing every time. So by clicking on this little icon, it will go where our patches is set and we can delete this. Now you can see the car is not moving. We don't need this shadow. So I'm just deleting it. Now we need the car is not looking forward to us. So we need to now to rotate the car. So in order to rotate the car, we can manually set it like this. Yeah, okay. This is in the front view, or you can click on the rotation tool and then rotate like this. So you can see it's not accurate. So instead of setting like this, I just revert it. And also the size of the car is huge. We can reduce it by decreasing the scale. Just typing the number 14, 14, 14. Okay, I think the size is good. Now when the users tap on the screen, you can see the car is moving according to the user steps. Now what we can do is change the car color when the user tapped on the screen. In order to change the car color, we need some UI elements. For this, I'll be using the picker UI to pick the color. I have created some A, B, C. So as this for the demo purpose, I created. So you can create your own custom car color or pictures in Photoshop or some other 2D software, and then you can import it in Spark AR, or you can right click on this. By using the replace me, you can replace this as well. So in order these textures to be worked with the picker UI, the picture should be the texture should be uncompressed. So for example, while we importing the textures into Spark AI Studio, it gets automatically compressed. So what we need to do is select all of these textures and then right click, and in the automatic we need to change the conversion types to none for all of this. Now we can assign the textures. The picker UI is not visible in the game view. In order to make it visible, we can check on this button. Now you can see the picker UI is visible, but when I tap on this, nothing is happening. So when I tap on A, B, or C, the color should be changed in the card demo. So how we can achieve this is we need to select the option index and then change it here. So the options pickers has a n number of types. It has the audio, boolean, color, number, pulse, etc. In order to use this, we can change the color because we are changing the color for the car. So I'm just changing the number to color, and the input is 3. So I'm just dragging the input to 3. Now we can choose any random color. I go with red, and blue looks good, blue and black. So in order this to work, the color should be in white. This is because this is the white texture. The white texture gets multiplied by this blue color. It has been showing us the blue color. So what here we are picker in the picker UI, we just are assigning the color. So we don't need the blue color. So we can make it as white. So this is the base color model, car texture model that we having. Now we need to multiply two of these colors and then assign it in the material. Now you can see the car color is getting changed. The options picker. We have A, B, C is working. So what does this does? The picker UI is gives us the index that we pick. The 2 stands for C and the 1 stands for B and then 0 stands for A. When you tap on the A icon, the 0 color is picked. Sorry, the 0 element is picked. So the 0th element here is the red. So the red element is get multiplied by this base texture. The base texture color is white. So these two textures gets multiplied and the final output is get assigned to the texture value. So this is the basic template for the plane tracking. So you can place here instead of car, you can place humans or home or some virtual characters or anything you like and place it in your real world and change their color or do some animations or trigger some animation or play some audios in the real world. So this is the basic templates of the world tracking. So I'm going to save it as a car. So this is for the part 3. So students, do you have any doubt in the part 3? Any doubts in the options picker or picker UI or how the color is assigned to the material? You can ask in the command. Okay, I hope everyone is good. Now we will be looking into the freeze frame. The freeze frame is nothing but after 2 seconds the frame is will be getting preset. We will be splitting our camera texture into 4 parts and we'll assign the camera textures into 4 equivalent. Uh, it will be in 4 individual quadrants and after 2 seconds one of the quadrants will get freezed and after 4 seconds the another quadrant will get freezed. So this is termed as the freeze frame. So this is one of the reachable filter in Spark AR. So I will be teaching you this. So what we need to do is first here we will be splitting the screen into 4 parts. So for this I have created a canvas and then the rectangle. The first one is part 1, part 2, part 3, part 4. So this is the UI pinning. So what does the pinning does? It just pins where it is. See, for example, the part 3 is pinned to the left and then top, and then part 2 you can pin it to the top and the right, and the part 3 you can pin it to bottom and the left, and the part 4 you can pin it to bottom and the right. So what the pinning does is it just pin it to the, see for example in part 4 we pin it to bottom and then right. So when I change the aspect ratio to iOS to iPad, you can see here these this is getting pinned to the bottom and then right. So that's why it's be in the center of the UI. In order to split the four screen, okay, let me explain you what is the differences between fixed and then relative. So fixed is nothing but here the screen is just 375 into 167. So we have an 100 pixels width and then 100 pixel height. The width is 100 pixels and then height is 900 pixels. When we change to relative, the value will be in 100 percentage. So you can see it from here. Here the value will be starting as 0 and then the bottom right will be starting at 100. So it will be 0 to 100 percentage. So the size of the part 4 plane is 26.667 percentage. So when we change the aspect ratio, it just maintains the aspect. So here now you can see the width and height of the aspect is 26.667. So this When we assign to fixed, the fixed aspect does not get changed when we change to relative. So we will be splitting the screen into four quadrants. Now you can see our screen is filtered into four quadrants: part 1, part 2, part 3, part 4. We can assign the camera texture to see here. In order to get the camera texture, you need to go to the camera, texture section, and then camera. You can see it is in the checkerboard pattern, so we need to assign the material. Change the shader types to flat. Now we just assign the camera texture. Now if we change the resolution, you can see it gets just fixed by the resolution. If we change the value from relative to fixed, you can see it's not getting stretched and it won't fit the aspect, and our original camera feed is getting visible. So this is why we will be changing from fixed to relative and making 50%. Now we can freeze our frame. So how will be freezing the frame? So when the user tap on the screen, after 2 seconds, the first quadrants will be getting freezed, and after 4 seconds, the second quadrants will getting freezed, and after 6 seconds, the third quadrant, and then 8 seconds, the fourth quadrant, and so on. So in order to use the freeze, we need to have the gesture. I'm going to create screen taps. So when the user taps on the screen, after 2 seconds, the screen should freeze. So delay frame is responsible for freezing the frames and then capturing and send it to the receiver. We cannot send from texture, so we need to use the shader interface. So what does the shader interface does is it just converts the shader into the texture, because the display frames, the delay frame input here is a texture, so we need to use the texture. I'm going to rename it as a part 1 delay frame, then right click and then make receiver. The receiver is a part 1 delay frame, and then the alpha. So in the before delay patch, we need to use the switch patch in order this to get worked. Now you can see we don't say anything. Now you can see when I tap on the screen, after 2 seconds, the first quadrant is getting freezed. Let me restart my scene. And now when I tap on the screen, after 2 seconds, the first quadrant is getting freezed. So this is how it works. When the users tap on the screen, we just passing the values to the switch pad, and then after 2 seconds, we are changing the values to the mix patch. So the mix pack just lerps the values. Since the value is when the alpha value is 0, it just takes the input 1 value. The input 1 value is 0, you can see here, and then when the value is 1, it just takes the input 2 value. The input 2 value is 5 here, you can see here. When the alpha value is 0.5, the value has been divided by 2, or 50% of this value is 2.5. You can see here the 2.5 is getting here. So this is how the mix patch works. So before tapping on the screen, likewise, before tapping on the screen, the camera texture value is getting rendered. So when after tapping on the screen, the part 1 delay frame, the delay frame that is preset texture is getting rendered. So now we need to do we need to copy and paste this to another set of quadrants. So instead of dragging and dropping this to every mix patch, we can use a send and receiver. So what does the send and receiver does? Receiver. This is common for the all of the 4 quadrants. So I can drag and command C, Mac to copy. You can see here I cannot move to the bottom. It's just preventing from me to move to the bottom. When I create some packs like animation, after that we can move to the bottom. So here the delay is 4. And then I'm copying and paste one more thing. Here the delay is 6. Here the delay is 8. Now we need to connect this patch to all of the delay patches. So right now I'm using the part 4 texture, part 3, part 2. Now we need to change the name of this as well, delay frames, because we are having the same name. Now I'm going to restart my scene and then tap on the screen. So after 2 seconds, the first curtain is getting placed, and after 4 seconds, the second curtain is getting placed, and after 6 seconds, the third and the fourth, and after 8 seconds, the fourth quadrant is getting placed. So this is how the delay frames in Spark AR works, and it's like a little bit of complex filters. You can add here some of the visual elements like GIS or particles and some audio like sound effects, and then you can create more creativity to this filters, and you can publish this. So yesterday I told you guys how to publish this. If you guys don't get this, let me tell you one more time. You need to click on this button to publish your filter, and then click on add experience. So what is the experience that you are targeting for the Instagram and Facebook? The sharing experience supports the Instagrams and Facebook, and the video calling experience the Messenger and Instagram. So as for now, we are using the sharing experience. We need to click on this and click on insert, and then press on done. By clicking on this upload button, the filter will get directly uploaded into the Spark AR, and also choose the platform as well. You just need to provide the demo video and icon, and after that you can publish the filter. Or otherwise, if you are familiar with exporting the file and then you need to go to the Spark AR help and export it manually, you can do that too. You can go to the Spark AR hub and click on this publish effect button, and then you can create a unique name for your filter, and you need to choose the AR export file. Let me show you once it's done. You need to select at least one of the categories, select the categories, and you should have the demo videos as well. The demo video should be recorded in the Instagrams or Facebook, and then recorded using the Instagram or Facebook filter, and then save it in your device, and then upload it into the Spark AR hub. You can provide the video thumbnail, or you can upload a custom image for your filter that will be shown at the bottom of your filter, and then you need to click on the submit button. So this is how you will be uploading your effect to the Spark AI Hub. We can write. Also, there will be a Spark AI filter policies. You need to check out when you are publishing some filters that you are matching the policies as well. Your filter should not use the squad or some other branches that you are not allowed to use, and it should have the performance as well. And your filter should not hide any capabilities. Say for example, you are using the hand tracking in your filter, but you do not use the hand tracking anywhere on the filter. You just importing the capabilities, but you have not used it anywhere and the filter. The filter will get rejected. So these are the Spark policies that you should visit and check before publishing your filter. And also Spark now supports the static text as well, and also the hashtag. Now you can use the static text in Spark AR and publish it in Spark AR. Spark AR won't reject the static text. So this is getting some time. So let me cancel it. So the AR export I'm mentioning is it here. You need to click on this export button and save your project. And you need to drag and drop it here. And you can upload the demo videos and icon and publish your effect. So this is for the part 4. So any questions or doubts, you can ask in the comment section. So I hope no one is having the doubt. So let me stop my screen.
So the students are all sitting in their computer lab and, working alongside. Let's wait for a question.
Okay.
I see. Yeah, so let's wait for the questions to come in.
Yeah, okay, sure. So students, you can ask any set of doubts in part 1, part 2, part 3, or part 4.
I don't see any questions coming in.
Yeah. Or if you guys stuck at some point or some part, let me explain you one more time so that you can figure it out easily.
I think there are no questions as of now. Let's call it a day, Adil. In case of any questions come up, I'll bother you with it.
Yeah, okay, okay, no issues on that. You
Thank you
can,
very much. Yeah, they can reach out to you, right?
yeah, yeah,
Right. So thank you very much for your time today.
yeah. Thank you. Yeah, thank you, Anamika.
Thank, thank you very much. Thanks.